physics gives us this purely objective view of reality, right? Like a cold, hard look at the universe as it really is, totally free from any human perspective. Well, what if I told you that entire idea, that view from nowhere, is basically a myth? In this explainer, we're going to figure out what objectivity actually means to a physicist. And trust me, the answer is way more connected to our own experience than you'd ever think.
So here's our game plan. First, we're going to look at that classic split between our inner subjective world and the outer objective one. Then we'll take apart that myth of the view from nowhere. After that, we'll replace it with the real definition of objectivity, see how physicists actually use it, and finally, watch how these two supposedly separate worlds come crashing back together.
All right, let's dive right in. We kind of grow up seeing the world as being split right down the middle. On one side, you've got the subjective world, your personal thoughts, your feelings, and on the other, the objective world of cold, hard physical facts. Yeah, so on one hand, you have physics, which tries to write the rule book for reality with math, trying its best to take the observer completely out of the picture. And on the other hand, you've got something called phenomenology, which really is just a fancy name for the study of our own conscious experience, of how things feel to us. One's all about what's out there, and the other is about what's in here. It really does feel like they operate in totally different universes. And the traditional thinking is that, sure, these two fields can talk to each other, but it's really just a nice little chat. It's polite. But they don't really have anything important to say about each other's work. But as we're about to find out, this whole picture might be built on a huge misunderstanding. And the root of that misunderstanding? It comes from a really popular but just deeply flawed idea of what it even means to be objective in the first place. You've seen this in pop science a million times, right? This idea that to be objective means you have to get this God's eye view of everything, a perspective that's completely removed from any single point of view, from any observer whatsoever. But is that how physics actually works? I mean, seriously? While that whole view from nowhere thing sounds super scientific and impressive, it's not at all how physicists find objective truth. The real method is, well, it's a lot more clever and way more elegant. So, okay, if objectivity isn't about removing perspective, what is it? It's about finding what doesn't change when you switch between different perspectives. This idea, this powerful concept, is the real foundation of objectivity in physics. It's called invariance. Invariance, it literally just means that which does not change. So an objective fact in physics is something that stays true no matter who is looking or where they're looking from. Just think about that for a second. It's not about having no point of view. It's about discovering what stays true across all possible points of view. Okay, let's make this super simple. Let's get out of the abstract. Picture a room, and there's a table right in the middle. Now we're going to put two people, let's call them A and B, in different corners of that room. Okay, so person A says the table is 5 feet from the door, and person B from their corner says, nope, the table is 10 feet from the window. Now, both of those statements are true, but they're subjective, right? They completely depend on where the observer is standing. But if they both walk over and measure the table itself, they will both find that it's 3 feet wide. That width, that is the invariant, objective truth. It doesn't change no matter what your perspective is. All right, so now let's see how physicists take this amazing core idea and turn it into a powerful toolkit for actually discovering objective reality. This is pretty much the fundamental recipe of modern physics. Step 1, you define your own perspective, your coordinate system. Step 2, you use these mathematical rules, they're called transformations, to translate what you see into what someone else would see from their perspective. And then step 3, and this is the absolute key, you look for what stayed the same during that translation. That thing that didn't change, that is objective reality. And this is just a brilliant example of how it works. In old-school classical mechanics, under what are called Galilean transformations, things like your velocity change depending on your perspective, but time, well, time was considered absolute. It was the great invariant for all observers. But then Einstein shows up, and in his special relativity, using Lorentz transformations, time itself becomes relative. The new bedrock, the new objective invariant, becomes the speed of light. Okay, let's just pause on that, because this is the whole thing right here. Objectivity isn't about wiping your viewpoint off the map. It's about a very careful, very systematic search for what endures across all possible viewpoints. The stuff that changes, that's subjective. The stuff that stays the same, that's objective. And this brings us to our final, and honestly,
most mind-blowing realization. This is where the world of pure physics and the world of our own lived experience finally come back together. This is the punchline, right here. The entire project of modern physics isn't about getting rid of the observer. It's about building a formal mathematical structure to connect all possible observers. It is, at its heart, a science of relating different perspectives.
Let's really let that sink in. The very thing we thought physics was trying to escape, subjectivity, perspective, the observer, it's actually the foundation it's built on. Think about it. You can't have invariance unless you first have different viewpoints, different variants to compare. To build its so-called objective world, physics first has to assume that there are subjects who can have a perspective in the first place. That inner world and that outer world, turns out they were never really separate. So we'll just leave you with this question. If this rock-solid idea of objectivity is actually built upon the very perspectives it's supposed to ignore, what other fundamental truths in science or just in our own lives have we been completely taking for granted?